Okay, let me work a couple of these just so you see the idea from which, and then I'll leave the answers, of course, where you can check your work to make sure you're doing those. But how do we go about when we want to see some circuit like this and we want to get them down to something that we can solve? For instance, what is one resistor that will represent these four resistors so that we can start to understand Ohm's law, which is saying there are three things that are related. Velocity is equal to the current times the resistance. Now that resistance is fine, but that's the resistance that, like, if I replaced all of those resistors in one single resistor, what would that be? Well, there's a couple of different strategies. If they're all in a row, for instance, you just add them up. That's what we said. If there was one resistor, two resistors, three. But this is not the case. These are two that are parallel, and then these two are series with each other. So probably what I want you to do is to think, oh, let's take any two that are in parallel like this, and get us an equivalent resistor for it. Okay? So the equivalent is literally this way. The 1 over the equivalent has got to be equal to 1 over 100 plus 1 over 250. Now this looks like it's complicated, but it's not bad at all. If you have a graphing calculator or a calculator that's got an inverse button on it, what I end up doing is I say, well, it's just the total of all the inverse numbers. Inverse means 1 over a number. You get an answer, and you just hit the inverse button for the answer. So if I were on the calculator, I would say 100, and the button looks like this, x to the minus 1. Okay, so I hit 100 x to the minus 1 plus 250 x to the minus 1. That's the button I'm hitting on the calculator. And then I hit equals. What I'm going to get is this number here, but instead of doing anything else, then I just hit x to the minus 1, and I have the answer. So 100 x to the minus 1 plus 250 x to the minus 1 equals, and then I hit x to the minus 1 again, and it flips this for me. And when I do that, I'm going to get a value for this to be 71.4 ohms. Okay, 71.4 ohms for those top two together. They're acting like one single resistor, 71.4 ohms. Let me do this bottom one again, but I won't go through the same details. When I take 350 inverse plus 200 inverse on the calculator, and I add those, hit the equal sign, and then hit inverse again, this one ends up becoming 127. I got to get my ohm symbol in there. 127 ohms. So I have the same thing as if now I just went in here and I went 1, 2. This is 71. This is 127. Can I figure out what the total of that is? Absolutely. I just add these when they're in a series. So this stuff all goes away. And this is just the total resistance of this is 71 plus 127, or 198. It's the same thing as using a 198 ohm resistor. Now the question is, oh, and that's all the question is. Here's your total equivalent resistor.